In this video, we're going to talk about the different powers of 10. When we talk about powers, we're talking about exponents. But in order to talk about exponents, we also need to talk about bases. Here we have 10 to the third power. This should look familiar to you because we use numbers written like this when we write numbers in scientific notation. The big number at the bottom, the 10, is our base. We call this the base because it sits at the bottom of the number, and this is the factor that we are multiplying over and over and over again. The exponent is the tiny number up on top of the base, and the exponent tells us how many times we're going to be multiplying the base by itself. So if we have 10 to the third, this means that our base is 10, the number that we're multiplying. So I'm going to start with at least one of those. And now my exponent tells me how many I should have, how many factors of 10. So here we have 3, so I have 1, 2, 3. So 10 to the third equals 10 times 10 times 10. This is equal to 1,000. So these are 3 different representations of the same number. If we're thinking about positive powers of 10, we're going to be moving our decimal point one space to the right, just like scientific notation. So if I have 1.0 times 10 to the first, I take my decimal point and I move it one space. So that's equal to 10. We get a larger number than what we started with. We can do the same thing for 10 to the second. So if I have 1.0 times 10 squared, I start with 1.0 and I move two spaces. So this is equal to 100. The pattern continues as we keep using higher and higher powers of 10. So if we have 1.0 times 10 to the third, that means I'm going to move my decimal point 2, 3 spaces, which gives us 1,000. Finally, if we take a look at 1.0 times 10 to the fourth, we start out with 1.0 and we move our decimal point 1, 2, 3, 4 spaces to the right. We fill in the zeros, and this is equal to 10,000. Okay? Each of these numbers has a positive exponent. Remember that positive exponents meant that we were dealing with large numbers. So we had big numbers with lots of zeros on the right-hand side. Anytime we had a positive exponent, we moved our decimal point to the right. Now we want to take a look and see at what patterns we can find with the negative powers of 10. So here, if we multiply by 10 to the negative first, this means that we have 1.0 and we move one space to the left. So now we have 0.1 or 0.10. You can include that if you want to. For the next one, if we have 1.0 times 10 to the negative second, that negative exponent tells us that we're going to move to the left, and we have a 2, so it's 2 spaces. So we count 1, 2, fill in the 0, and that's equal to 0.01. Again, when we have this extra 0 hanging out here on the end to the right of a decimal point, we can cut it off. We don't need to include it in our answer. So now let's try the next one. We're going to multiply by 10 to the negative third. So we have 1.0. We move 1, 2, 3 spaces. 3 spaces because our exponent was a 3, and to the left because it was negative. We fill in the empty gaps with zeros, and then we write our final answer. So we have 0.001, and we're allowed to cut this extra 0 off because it's at the end on the right. Go ahead and pause the video and try the last one on your own. We want to know what is 1.0 times 10 to the negative fourth. So we have 1.0 times 10 to the negative fourth. Again, we start with our 1.0. Our exponent is negative, which means we're moving our decimal point to the left, and it's a 4, so we're going to move 4 spaces. We count 1, 2, 3, 4, draw our new decimal point, and fill in the blanks. So now we have 0.0001, We can chop off this extra 0 at the end on the right because we no longer need it. If we look at each of these, we can use place value to write these decimals in another way. So 0.1 is equal to 1 over 10 because that is in the tenths place. If we're 2 spaces out from the decimal point, this is the same thing as the hundredths place. So if I have a 1, this is 1 over 100. If I'm 3 spaces out from the decimal point, that's the thousandths place. So this decimal is 1/1000th, so I have 1 over 1000. Finally, in the purple, I'm 4 spaces away from the decimal point, and that's 1/10,000th. So I have 1 over 10,000. Notice that the only numbers I see here are 1s and 0s. There's no negative signs, and there's no 2s, 3s, 4s, or 5s. There's only ever going to be 1s and 0s when dealing with powers of 10. Another way to write each of these fractions would be 1 over 10 to the first, 1 over 10 squared, 1 over 10 cubed, and 1 over 10 to the fourth. We can take that exponent that's negative and make it positive by moving it into the denominator of a fraction. So now, we want to be able to identify powers of 10 in their different forms and circle numbers that are equivalent to a given power of 10. So here we have 10 to the negative third. If I start off with that, I think about 1.0 times 10 to the negative third. It's negative, so I'm going to move my decimal point to the left, and I'm going to move it 3 spaces. So I count 1, 2, 3. I fill in my zeros, and I have 0.001. So right away I can see that that's here, so I can circle that answer. This answer has 2 things wrong with it. It's negative, and it's got a 3. Remember that powers of 10 will only be positive, and they will only have 0s and 1s. So this is out. Likewise, this answer has a negative sign in front, so that's not good. If we're 3 spaces away from the decimal point, that is the thousandth place. So I have 1 over 1000, which is also equivalent to this answer. We'll take a look at the next one. We have 10 to the negative first. So it's the same thing as 1.0 times 10 to the negative first. It's a negative exponent, so I'm moving to the left, and it's a 1, so I'm moving 1 space. So I go ahead and move, and I end up with 0.1. Not negative 0.1, and not 10. When I'm 1 space to the right of the decimal point, this is the tenths place. So my decimal is going to be equivalent to 1/10. Go ahead and pause the video and see if you can identify the numbers that are equivalent to 10 to the negative second. 10 to the negative second is the same thing as 1.0 times 10 to the negative second, and I'm going to move 2 spaces to the left. So this is equal to 0.01. That's not the same thing as 100, and it's not the same thing as negative 0.01. When I'm 2 spaces to the right of the decimal point, this is the same thing as the hundredths place. So 0.01 is 1 over 100. Another way to write 100 is 1 over 10 times 10. And when we have the same number being multiplied by itself, we can use exponents as a shortcut. So 10 times 10 can be written as 10 to the second power because we have 2 tens, and so 1 over 10 squared is also equivalent. For the last one, we have 10 cubed. This is 10 to the third power, and it's a positive power, so I know that I can get rid of all of the small numbers. So 1 over 1000 is too small, 0.001 is too small, 0.003 has a 3 in it, so that's automatically out, and 10 to the third we think must be 1000, so we have 10 times 10 times 10 because we have the third exponent. 10 times 10 is 100, times 10 is 1000. Go ahead and pause the video and see if you can match the correct decimal and fraction for 10 to the negative 1/3 power. Alright, for this one, we can go ahead and eliminate answer choices before we even have to start thinking about what the possible answer could be. This answer and this answer both have negative signs, and remember that negative exponents do not make the number negative. They just mean that we're dealing with a small number. So those two are automatically out. This answer choice has a 3 in it, not a 1 or a 0, so that is out, which means the only answer choice that's left has to be correct, 0.001. If we think about how we get that answer, we have 1.0 times 10 to the negative third. The negative exponent means we're moving the decimal point to the left, and the 3 means we're going to go 3 spaces. So I count 1, 2, 3, fill in our blanks, and we have 0.001, which is the answer that we selected. 0.0001 is in the thousandths place, so that's the same thing as 1 over 1,000. But 1,000 is the same thing as 10 times 10 times 10, which is 10 to the third power. So we have 1 over 10 to the third power as our answer. Whenever we have a 10 in the denominator or in the bottom of a fraction, the exponent will never be negative. We move it down there to make it a positive exponent. So this answer is no good. The next answer and the next one after that have negatives out in front of the fraction. So those are also no good. Remember that the negative exponent just means we're dealing with a small number, not a negative one. Go ahead and pause the video and try the next one on your own. Alright, for this one we were dealing with 10 to the negative second. So again, we can do some eliminating of our answer choices and save ourselves a little bit of work if we don't have to do it. This answer choice and this answer choice are negative, so right away we can rule those out. This one has a 2 in it, which is not a 1 or a 0, so that must be incorrect. That leaves us with 0.01. 10 to the negative second times 1 means that we're going to move our decimal point to the left 2 spaces. So I count 1, 2 spaces, and I have 0.01, which is the decimal that we got. If I have 2 digits to the left or the right of the decimal point, that's the 100th place. So this is 1 over 100, which is the answer that we chose. This answer has a negative sign out in front, as does this one, so those are both incorrect. The issue with this answer is that the negative exponent is still there even though we moved it down. So that one is also incorrect.